We are now switching to what we refer to as the types of errors. Our very first type is what we refer to as the absolute error. So we are saying that the absolute error is the magnitude of the error. So if you have any error and you want to get its magnitude, you just put magnitude symbols on the error. So if e subscript x is the error in x, then the actual size of the error disregarding the sign is what we call the absolute error. I am underlining that, implying that if ex is the error, because we are saying for the magnitude you add, for the absolute you add magnitude symbols, then the absolute error in this becomes the magnitude of ex, where ex is the error in the approximate value small x. Part B is what we refer to as the relative error, and we are saying because this side we are going to be dealing more with the error propagations, our relative error is now going to change to the fractional error in an approximation. If you are in trapezium rule, it becomes the fractional error in the exact. So it is always expressed as a fraction of the approximation if you are in error propagation. And we are saying relative error is equal to absolute error over the approximation. So if our absolute error is this and the approximate variable is small x, then the relative error becomes the magnitude of the error in the approximate value small x over the approximation small x. Part C is to do with the percentage error. We said percentage error is relative error times 100%. So our relative error is absolute over approximation. So you get this times 100%, which is as good as having this times 100%. That is if you want the percentage error. So we are going to use this information to try and work out question 1. So question 1 says that the numbers A, which is 26.23, B, which is 13.18, and C, which is 5.1, are calculated with percentage errors 4, 3, and 2 respectively. They want us to calculate the absolute error in A, B, and C. Now, because they have given us the percentage errors, it means we are going to use this. We are going to use this fact that the percentage error is absolute error over the approximation times 100. We have the percentage error, we have the approximation, and we want the absolute error in each of the variables A, B, and C. So the very first step is to let the error to be represented by something. If we are working on small a, we begin by rating. So we are rating EA to be the error in small a. Our A is 26.23. So the percentage error in small a is absolute error in A over the approximation times 100%. So remember, we have supposed our error to be EA. So percentage error in A is this, is absolute error in A over A times 100%. We are now replacing, where there is percentage error, we are putting a 4. So we are going to have 4 is now equal to EA over 26.23 times 100. And when you make this the subject, we shall find out that EA is 1.0492, and this becomes the absolute error in small a. The same applies to small b. We shall say that percentage error in small b is absolute error in small b over the approximation times 100%. So here there is percentage error, we put this. Absolute error is the magnitude of the error in P. Remember we said you begin by rating. And finally we shall realize that the magnitude of the error in P is 0.3954. So you will try out for small c and you try and calculate the magnitude of the error in C, or the absolute error in C. You will check and see whether the answer will be 0.102. So that is that. If you want to use the percentage error to calculate the absolute errors in different variables which are representing some known values that have been rounded to a given number of decimal places. Now sometimes it might not be set like this. You see, for this one they said for this particular one they told us that the numbers this are calculated with the percentage errors. Because they have already stated that these are percentage errors, there is no need to put percent on this, because it is already saying that these are percentage errors. Now sometimes they may not say that they are percentage errors, but they instead tell you that they are calculated with errors 4%, 3%, and 2%. You still use this, because what would have been provided would be percentage errors. For example, in this case, where we have the exercise, they are telling us that the number x, which is negative 0.94, and y, which is 1.3, are measured with errors 2% and 4% respectively. Because these have percentage symbols, it means they are percentage errors, and therefore we use this fact to calculate the absolute error in x and also the absolute error in y. You should also note that this magnitude symbol extends up the downer part, implying that if this x is negative, we shall finally have the magnitude of the error when it is positive, because the magnitude symbols imply that disregard the negative and take the positive of that approximate value. Now in question 2, they are telling us that the numbers w, which is 11.163, and z, which is 2.61, are measured with the percentage errors 1 and 0.5, and they want us to find the absolute errors in w and z. Now this one is synonymous to what we have just covered, for which they are instead mentioning that these are percentage errors. So you work as we have worked out. So those are the two forms of how they can set things to do with the percentage errors. Now in part D, we are going to look at the maximum possible error in any approximate value. We are saying that this depends on the number of decimal places a number or a value is written to. It is obtained from 0.5 times 10 power negative n, where this n represents the number of decimal places. For example, the numbers A, which is 26.23, B, which is 13.181, C, which is 5.1, D, which is negative 5.1, and E, which is a 4, are all measured correct the nearest decimal places. Find the possible errors, find the maximum possible errors in A, B, C, D, and E. It doesn't matter what sign is on the approximate value. What is important are the number of decimal places. So we are going to begin by rating. Because our first approximate value is small a, we are saying let EA be the error small a, so that that maximum possible error in small a will become 0.5 times 10 power negative n. Now you go back to small a and count how many decimal places does it contain. It has 1, 2. So it will become 0.5 times 10 power negative 2. And eventually the maximum possible error in A becomes this. For B is a 13.181. So our error in B becomes 0.5 times 10 power negative n. Where there is n, we are going to put 1, 2, 3 because it has 3 decimal places. And this will become 0.5 times 10 power negative 3, which reduces to 0.0005. So that would be the maximum possible error in a B. Please note that for these questions of this nature, where we are meant to use the maximum possible error, they do not quote the percentage errors in the approximate values, but they instead give you only the approximate values. So if you're given only the approximate values, then it means the only way to get the error in the approximate value, it is by using this one. Otherwise, where the question quotes the approximate values and the percentage errors in them, then we use the first approach. So for C has only 1 decimal place, and we shall put a negative 1 up there because our n is 1. D has also only 1 decimal place. Even when D is negative, our interest is on the decimal places. So for D, which is negative 5.1, we begin by rating. Our error in D becomes 0.5 times 10 power negative n. You go back to this. You don't look at the sign on D, but you look at the number of decimal places. It has only 1 decimal place. So it is 0.5 times 10 power negative 1, which is a 0.05. Then for small e, which is a 4, this one has no decimal places, so n becomes 0, not negative 0. So here there is n, we are going to put a 0, and the error in the approximate value e, which is a 4, is going to become 0.5. So it is from that basis that we are noting that a is equal to 4 and a is equal to 4.0. They are two different approximate values, and therefore the error in this is not the error in this. If a is equal to 4, then the error in a becomes 0.5. And when a is equal to 4.0, then the error in a becomes 0.05. So you should note that 4 is not 4.0 in this topic that we are covering. So in an exercise, you will think about this and that one. Then lastly, sometimes we may have the approximate value being written in this sense. The numbers that are expressed in the following forms. This is how we read off the errors if a number is expressed in this form. If a is equal to 5.2 plus or minus 0.05, whatever comes after plus or minus, if the value is written like this, it means what comes after plus or minus is the error in the first one. So if a is 5.2 plus or minus 0.05, it means the error in a is this one at the extreme. You don't recalculate. If b is 43 plus or minus 0.03, it means the error in b is 0.03. It would now imply that the error in this 43 is 0.03. The error in 5.2 is 0.05. That is what these statements imply. So you will reason out what the error in C is if C is expressed like that, what the error in D is if D is expressed like that, and what the error in E is if E is expressed like that. Then away from that, sometimes it might not be about values, and this time it is about angles. Now in applied, we do not work with degrees, so it means you have to convert the final answer to radians by changing it to pi form. So if A is 30 degrees, then the error in A becomes 0.5 times 10 power negative n over 180 times pi. Where there is n, we put the number of decimal places any angle is written to. Because this is 30 degrees and it is a whole number, it is written to no decimal place, implying that where there is n, we are going to put a 0. So the error in A becomes 0.5 times 10 power 0. This is not degrees, but now this 0 is representing the number of decimal places on the angle. So we shall finally have our error in A as pi over 360. In the exercise, you will think about what the error in B is if B is 43.1 degrees. You will think about what the error in C is if C is negative 60 degrees. The same applies to D. And finally, the last one, which is a K. We said if you're given something like this, it now means that what comes after plus or minus is the error in the first one. So what you will do is only to convert this to pi form and have 0.5 degrees expressed in this form. So it will eventually be 0.5 over 180 times pi, and that would give you the error in K. So you can work out and you share your solutions to my email, which is Asumani Mutiaba 4 @gmail.com. So we are now switching to what we call the error propagation. Thank you for listening.